Okay.
Graphs, the concept of graphs in photoelectric effect. This is a very important concept because in your NEET exam, not in IIT but in NEET exam, many questions from this may come. And it is a very easy part, it's not difficult. What are the types of graphs that we have in photoelectric effect chapter? We have several graphs. 4 graphs are there. Totally 4 graphs are there. Out of them, the first graph is on x-axis. First graph and second graph both are lookalike graphs. On x-axis, always potential will be there. What is this potential? Potential of anode. Potential of the anode. That is common for both first graph and second graph.
There are only
On the
two types
y-axis,
of 4 types of graphs. Okay.
both the types of graphs have x-axis same. Y-axis
How
only
many
things
types
will
of graphs are there again? Sir? Someone called me. I couldn't hear you.
What's it? Okay. Now,
Yes, sir.
the first graph has something else here. On the y-axis, what is there is photo current. Photo current emitted. Photo current emitted. That's on the y-axis. First, let us discuss about the first graph. Then I will tell you about the second graph. Okay. So what happens in the first graph is when you're increasing, not applying, it means when you're increasing the applied potential difference between the anode and cathode, the photo current increases. Increase. But how much will it increase? It will increase like this. But after some time, the photocurrent will stabilize. Okay. After some time, what happens to the photocurrent? It will stabilize. It will remain constant. So it will be like this. It will be like this. This is the situation. This is for an intensity. This is for an particular intensity of the incident light. Intensity I1. Okay. This is for intensity I1. Now what happens? If the intensity is increased, if the intensity is increased, intensity of the incident light is increased, then what happens? It will go to a higher graph like this. So several graphs you can plot. They will all be like this. Okay? So what happens is, did you get this? Did you understand?
These are intensity graphs.
No, for different intensities, I1, this may be some other intensity.
For finding a particular intensity.
Yes, Vishal.
For finding a particular intensity, you use these kind of graphs.
At a particular intensity, they will look like this.
Yeah.
When these graphs are back prolonged, all these graphs will meet on the negative x-axis at the same point called as minus V0. This is only called as stopping potential. Okay. This is called as stopping potential. At this point, all the 3 graphs or 4 graphs or 5 graphs, all of them will meet. Stopping potential, you know what is stopping potential, no? The maximum amount of or the minimum amount of potential that you have to apply across the negative anode to stop the fastest moving electron. That is called as stopping potential. That you know. Here, what are I1, I2, I3 looking like? I3 is greater than I2 is greater than I1. What does this mean? They mean intensities of incident light. Is this understood? First graph?
Yeah, I know the intensities are higher just by looking at the diagram because the third one is extending at a higher, altitude.
It is more. See that?
Yeah.
So can I rub the first graph? Now I will explain the second graph.
Can I just draw it somewhere?
Different frequencies, same intensity. Okay, all these lines now I'm going to draw are having the same intensity. Intensity means what? What is the meaning of intensity? Amount of number of photons
Like
present in that
I3,
line.
I2, I1, all of those. In
Intensity
the
means
first one, sir, I know. In the first one, I3 was greater than I2, which was greater than I1. But over here, I2 is equal to I1 is equal to I3,
yes.
but frequencies are different.
New,
New is
not V. New,
new is different. Yeah, new is different.
Yes, new is different. So these graphs will look something like this. They will start from a point like this, and then they will go. This is for first frequency. Then for the second frequency, they will start like this. But what will happen is these two lines will meet. All the lines will meet here. All the lines start from different frequencies, but they will all meet. Why do they meet? Because their intensity is same. That is the reason they will all meet. Even though they are different frequencies,
Okay.
that's why on x-axis they are starting from different frequencies. This is nu not 1. This is
So
nu
this is the
not,
opposite of the first graph.
yeah, that's correct. Nu 1, nu 2, nu 3. These are all threshold frequencies. Okay. But intensities are same
Sir,
here.
so in the first one, nu1 is equal to nu2 is equal to nu2.
Yeah, in
Then
the
can we
first
say that in the
equation,
first graph, nu1 is
first
equal to
graph,
nu2?
in this first graph, nu1 was equal to nu2 was equal to nu2, nu3. Okay. But in the second graph,
Yeah.
what is there? Nu1 is different. Nu3
Nu1,
is
nu3
greater.
greater than nu2. Okay,
These are
yeah,
greater.
Okay, got
Here,
it.
nu naught 1 is equal to nu naught 2 is equal to nu naught 3 in the first graph. Okay. In the first graph, frequencies were same, intensities were different. In the second graph, intensities are same, frequencies are different. So that is why these graphs look like this. Okay, is it clear?
Yes,
What is the new? These are graphs for nu naught 1, nu naught 2, nu naught 3. Okay. So, but what will be on the x-axis? These coordinates are called as stopping potentials only.
okay.
Okay. So don't get confused. I will write these above, little bit above. I will write. Here, what is the x-coordinate here? V naught 3. This is what V naught 2. V naught 1. On this graph here you are right. Nu naught 3. Nu naught what here? Nu naught 2. Nu naught 1. All have different frequencies. Okay. Such that nu naught 3 is greater than nu naught 2 is greater than nu naught 1. Okay. They are different frequencies, but these are negative values, negative stopping potentials. See, that's why in the second graph, different stopping potentials we are getting. Okay. But in the first graph, how was the first graph? All were having same stopping potential. They used to start from here, is it or not? They used to go like this. Is it or not? If you
Yes,
keep
sir.
on drawing from the same point, you will get the graph. First graph was like that. But if you see second graph, it's not like that. Second graph is different stopping potential, but same intensity. Is it understood?
Yes, sir.
Yes. Now, this difference is there, no? From here to here, what is the difference called as? Or from here to here, this is called as saturation current. Saturation current. This value of current is called as, if you, what is saturation current mean? You keep on plot, they will all finally reach a value of current. So if you plot them on the y-axis like this, they will reach some IS, I. This is not intensity, okay? Don't get confused. This is not capital I, this is small I. Small I. On y-axis, current is there. So current is represented by small I. These are intensity. That is different situation. This is called small is, not stopping current, okay? Saturation current. It's called as
Okay.
saturation current. I, small I, subscript S. Is that understood?
Yes, sir.
Okay. Saturation current, small is. You can note down.
I've written it down, sir.
Third graph, the very important graph is the third graph, which is of physical, not of physical significance, but of numerical significance. Third graph is very much useful for our neat numericals. Okay. Third graph, again, what does it have? It also has an x-axis and it also has a y-axis. Only difference in this third graph and the first, second two graphs is that everything changes here. X-axis also changed, y-axis also changed. On the x-axis, what we are going to have is frequency of incident light. On the x-axis, what you're going to have is frequency of incident light. Whatever that light may be, yellow color light, white color, whatever, will have its own frequency. Different frequencies of light are taken, and then their corresponding stopping potentials. Corresponding stopping potentials. The corresponding stopping potentials are plotted on the y-axis. Different stopping potentials are plotted on the y-axis for each of the frequency of incident light. For example, this graph has been derived from the second graph. The third graph is a byproduct of the second graph. In the second graph, what we have is frequency, different frequencies we are taking, right? For different
Yeah.
frequencies, let me again recall your memory of the second graph. In the second graph, if you see what was
In the
happening.
second graph, the frequencies were different, but the end
Yeah.
product, which is the current
They were all
produced,
going
were all
to the
the
same
same.
saturation current, is it or not?
Yeah. The
That is
saturation
because
current was for all three was the same.
they were all merging at one point. What you
Yeah,
are
which is the
observing
current
here is, you see,
maximum
here
voltage.
on x-axis, we have minus V03, minus V02, then minus V01. But
One.
for these different stopping potentials, these are different stopping potentials. Each have their own threshold frequencies, is it or not? Nu naught
Yeah.
3,
Nu naught 1, nu naught 2,
nu
nu
naught
naught
2.
3.
Yeah,
Nu naught 3
that's
is
what we
greater.
are
Nu
going
naught
to
3
do
is
here.
greater than nu naught 1 is greater than nu naught 3 is greater than nu naught 2, which is greater than nu naught 1.
Yes, correct. So those different values of nu naughts means what will come on the x-axis here? Nu naught 1,
Nu
nu
naught
naught
1,
2,
2,
nu
nu
naught
naught 3.
3. These are the frequencies. Okay, on the x-axis.
Are the frequencies here greater than each other as well, or are they equal to
Of
each
course,
other?
they are greater. You can see these
Okay,
numbers.
nu
This
naught
may be some 1, this may be some 2, this may be 3. When you go on the left-hand side, numbers increase, right?
Yeah.
It's quite obvious. Huh? So on the y-axis, what you're going to do? New stopping potentials you have to take. V01, V02, V03. I hope you know these are increasing upwards. Okay.
Wait, is that V or is that new? I can't see.
This
That's
is
V, right?
new. This is VVV. Stopping
Electric
potential.
potential.
Stopping potential I wrote here. Stopping
Oh, stopping
potential.
potential.
V0. What I wrote here, frequency of
So
incident.
stopping potential, sir, I have a question. Since the frequency of 3 is greater, won't the stopping potential of 3 be lesser than 2?
Stopping potential?
Is it V, is V0 3 smaller than V0 2, smaller than V0 1?
No, greater. See, greater numbers will be upwards,
Greater
no?
than stopping potential as well, because I thought that I thought because the frequency is higher for V0 3, I mean nu0 3, the stopping potential would be significantly lesser than that of V0 1.
They are directly proportional. How can they be inversely proportional? When
Oh, they're
frequency
directly
increases,
proportional.
stopping potential increases.
Okay.
When frequency increases, stopping potential obviously increases.
Oh, okay.
Incident light's frequency is increasing, the stopping potential also will increase. That's what you observe from the second graph, is it or not? See here, for V naught 3, you have nu naught 3, which is quite higher than the nu naught 2, and which is higher than nu naught 1. Is it or not? So
Oh,
when you
wait,
plot
yeah, yeah,
the,
yeah, yeah, yeah.
huh? So now when you plot these graphs, what happens is you get straight lines like this. You get straight lines like this, like this. You get like this. You get straight lines like this. And what are these straight lines representing? These straight lines are representing the direct proportionality between stopping potential and frequency. These are directly representing the relation between stopping potential on the y-axis with frequency are directly proportional. And when you actually back prolong them means you're going to, what are you going to do? Like this. You're going to back prolong these graphs. What happens is they will meet on the y-axis somewhere. Actually, these are the values of the stopping potential. These are the values of stopping potential. This is actually minus V naught 1, which I wrote here is actually here. Which I wrote here is actually here. The numerical value you will get here. Is it understood? I am writing it on the y-axis upwards for your understanding. But actually they will be they are negative values. No, you can't get them on the y-axis upwards. You will get
Yes,
them on the y-axis downwards. Negative values. Is it understood, Vishal?
yes.
Okay, I just wrote these here for your understanding. But actually, we will get them on the lower y-axis. So these are the frequency of incident light on the x-axis and stopping potentials on the y-axis. Then this graph cuts the y-axis. The y-intercept is exactly the stopping potential. Okay.
Got it.
So very important thing is stopping potential increases linearly with the frequency of incident radiation for a given
So what's the
photosensitive
difference
material.
between
This is very important. Okay.
what?
Frequency and stopping potential are linearly related. Is it or not? They are linearly related. That's why the straight lines are coming.
Oh, okay. Frequency and stopping potential.
Are linearly related.
What does that mean?
Linearly related means direct proportionality.
Oh, okay.
Direct proportionality. In English, we call that linear relation. Okay. Have you noted down? Should be there. Y is equal to mx plus c or minus c. Then what is x? X is the variable. C is the constant. So such an
Yeah.
equation in that the slope m coincides with or is equal to, if you compare these two lines, these two equations, the slope m is equal to like h by e from this equation. Is this understood? This is the
Yes, sir.
given equation with the points A, B and C. This is the photoelectric equation. We change the photoelectric equation like this so that it looks like a straight line equation. Compare with your 10 standard straight line equation. Y is equal to plus or mx plus or minus c. Then what is slope m there? Here. That there it was m. Here it is h by e. Understood? And the variable x. If you see the variable x, there you can see x. No, here. That x is like, if you write x, this x is like mu. And this constant c is like, this whole thing is a constant. Understood?
Yes, sir.
So variable, the slope. But there is another formula. There is another formula in straight lines of geometry. You have slope formula. What is slope formula? There is a formula for slope. Y2 minus y1 by x2 minus x1. This is the formula for slopes. Okay. What are the y coordinates in this situation? And what are the x coordinates in this situation? Tell me. Smart this.
Y coordinate is electric potential and X coordinate is this one,
Y
frequency.
coordinate. Y coordinate. This is the y2 minus y1. This is the slope, no? How do you take
Yeah.
the slope for two?
CB, E minus
Yeah.
AB
So
by,
slope m.
I mean, E into AB by
Slope m is
CB.
nothing but the y coordinate by x coordinate, which is
Okay.
nothing but AB by CD. Okay. But you already have h by E. So you just write AB by
Hold on,
CD.
this is,
CD.
oh, okay, okay, okay.
Then what he is asking, you will get the answer. Small h is how much? E will go that side. E into AB by CD. Is it understood? That
Yes,
is
sir.
the Planck's constant h value from this graph. Is it understood clearly?
Yes, sir.
Okay. Note it, please. 16th question, very, very important question. We're going to do that